Lesson 1. What is an AI project? Understanding scope, characteristics, and value. In this lesson, we begin by understanding what an AI project truly is and why it is fundamentally different from traditional technology projects. Many organizations make the mistake of treating AI projects like standard software initiatives, but this misunderstanding often leads to failure. AI projects are not about building fixed features that behave the same way every time. Instead, they focus on delivering probabilistic intelligence, meaning the system learns from data and improves over time. An AI project operates in an environment where outcomes are not always guaranteed. Unlike traditional systems where rules are explicitly programmed, AI systems learn patterns and make predictions based on data. This introduces both opportunity and uncertainty. As a project manager, your role is not just to deliver a product, but to guide a learning system toward business value. It is important to recognize that AI projects are dynamic. They evolve as new data becomes available and as models are refined. This means success is not defined by a one-time delivery, but by continuous improvement and measurable impact. Now that we understand the foundation of AI projects, let us move into a deeper definition of what actually makes a project an AI project. What makes a project an AI project? An AI project is a structured initiative that uses data-driven models to learn, predict, and improve over time. At its core, AI is about discovering patterns in data and using those patterns to generate meaningful outputs. Curious, these outputs can range from predictions, such as forecasting customer behavior, to generating entirely new content like reports or recommendations. There are 4 essential capabilities that define an AI project. First, AI systems learn patterns by identifying hidden relationships within data. Second, they make predictions by forecasting outcomes and behaviors. Third, they generate outputs, which may include insights, decisions, or content. Finally, they improve over time as they are exposed to more data and feedback. A critical concept to understand is that AI delivers capability, not certainty. Traditional software produces predictable results based on predefined rules. In contrast, AI systems produce probabilistic results, meaning they provide likelihoods rather than guarantees. Real-world examples include predicting customer churn, detecting fraud in real time, generating automated reports, and supporting complex decision-making processes. Now that we understand what defines an AI project, let us explore how AI projects differ from traditional IT projects in practice. How AI projects differ from traditional IT projects. AI projects require a completely different management approach compared to traditional IT projects. Instead of managing fixed deliverables, you are managing a system that learns and evolves. Curious. This shift introduces several key characteristics that every AI project manager must understand. First, AI projects are data-dependent. Without high-quality data, the model cannot perform effectively. Second, they are probabilistic. Outputs are not guaranteed but are expressed as confidence levels. Third, they are iterative. Models improve through continuous experimentation, testing, and refinement. Fourth, AI projects are risk-sensitive. Issues such as bias, model drift, and ethical concerns can significantly impact outcomes. Finally, timelines are uncertain. Size. Unlike traditional projects that follow predictable schedules, AI breakthroughs do not happen in a linear fashion. The most important insight here is that you are managing learning, not just delivery. This requires flexibility, experimentation, and a willingness to embrace uncertainty. Understanding these differences is critical because it shapes how you plan, execute, and measure success in AI projects. Now that we understand these characteristics, let us look at what an AI project actually includes in terms of scope. What does an AI project usually include? To successfully manage an AI project, you must understand its full scope. Many projects fail because teams underestimate what is required beyond model development. The first component is business problem definition. This involves clearly identifying objectives, success metrics, and constraints. Without this clarity, even the best AI model will fail to deliver value. Next is data collection and preparation. This includes gathering, cleaning, labeling, and validating data. This stage often consumes the majority of project time. The third stage is model development and training, where algorithms are built, tested, and optimized. This is followed by validation and testing to ensure the model is accurate, fair, and reliable. After that comes deployment and monitoring. AI systems must be continuously monitored in production because performance can degrade over time. Finally, ethical and compliance checks ensure the system meets regulatory and ethical standards. It is also important to avoid common misconceptions, such as expecting perfect accuracy or assuming AI requires no human oversight. The golden rule is that AI projects do not end at deployment. Continuous monitoring is essential. Now that we understand scope, let us explore why organizations invest in AI projects. What does an AI project usually include? To successfully manage an AI project, you must understand its full scope. Many projects fail because teams underestimate what is required beyond model development. The first component is business problem definition. This involves clearly identifying objectives, success metrics, and constraints. Without this clarity, even the best AI model will fail to deliver value. Next is data collection and preparation. This includes gathering, cleaning, labeling, and validating data. This stage often consumes the majority of project time. The third stage is model development and training, where algorithms are built, tested, and optimized. This is followed by validation and testing to ensure the model is accurate, fair, and reliable. After that comes deployment and monitoring. AI systems must be continuously monitored in production because performance can degrade over time. Finally, ethical and compliance checks ensure the system meets regulatory and ethical standards. It is also important to avoid common misconceptions, such as expecting perfect accuracy or assuming AI requires no human oversight. The golden rule is that AI projects do not end at deployment. Continuous monitoring is essential. Now that we understand scope, let us explore why organizations invest in AI projects. Key takeaways: what you've learned about AI projects. In this lesson, we have explored the foundational concepts of AI projects and what makes them unique. First, AI projects are fundamentally different from traditional IT projects. They are data-driven, probabilistic, and iterative. Instead of delivering fixed outputs, they deliver evolving capabilities. Curious. Second, we learned that scope must include post-deployment activities. Monitoring, maintenance, and continuous improvement are essential because AI systems change over time. Thoughtful. Third, we emphasize that value comes from alignment with business goals. Technical excellence alone is not enough. AI must solve real business problems to be meaningful. Exhales. You now understand what defines an AI project, including how data-driven models learn, predict, and improve. You also understand how AI differs from traditional IT, particularly in terms of uncertainty and iteration. Additionally, you have learned the full scope of AI initiatives, from problem definition to ongoing monitoring, and why organizations invest in AI to drive efficiency, innovation, and competitive advantage. As we move forward, we will build on this foundation. Now that you understand what an AI project manager is and the role they play, the next step is to understand how this role is different from traditional project management. Because managing AI projects is not just an extension of normal projects. It requires a completely different mindset, especially when dealing with uncertainty, data, and evolving models. So in the next lesson, we will break down the key differences between AI project managers and traditional project managers. AI project manager versus traditional project manager. In this lesson, we are exploring one of the most important shifts in modern project management, the difference between a traditional project manager and an AI project manager. At first glance, the titles may seem identical, but the responsibilities, mindset, and leadership approach are fundamentally different. Traditional project management was built around certainty, structured planning, and predictable execution. However, AI projects operate in a completely different environment, one that is driven by data, uncertainty, and continuous learning. This means the role of the project manager must evolve. As an AI project manager, you are not just managing timelines and deliverables. You are guiding a system that learns, adapts, and improves over time. You are working with probabilities instead of guarantees, and you are responsible for ensuring that the outcomes deliver real business value. This shift requires a new mindset. It requires flexibility, strategic thinking, and the ability to manage ambiguity. It also requires understanding how data, models, and business goals connect. In this lesson, we will break down these differences clearly so you can understand how to operate effectively in AI-driven environments. Now let us begin by understanding the core idea behind this shift in the lesson overview.
Same title, very different battlefield. Although the title Project Manager remains the same, the reality of the role has changed dramatically in the world of AI. This slide introduces the core idea that you are stepping into a completely different battlefield. In traditional environments, project managers thrive on certainty. They work with defined requirements, structured timelines, and predictable outcomes. Success is measured by delivering projects on time, within budget, and according to scope. However, AI project management operates under a different set of conditions. Here, ambiguity is normal. Experimentation is required. Continuous learning is part of the process. Instead of controlling every variable, you are navigating uncertainty.
The key learning objectives for this lesson are twofold. First, you will learn how to distinguish between a traditional project manager and an AI project manager. Second, you will understand why AI projects demand a completely different leadership approach. The core tension is clear. Traditional project management is about control and predictability. AI project management is about adaptability and learning. Understanding this difference is critical because it shapes how you lead teams, manage stakeholders, and define success. Now that we understand the battlefield, let us examine how traditional project management actually works. How traditional project management works. Traditional project management follows a structured and predictable approach. It is built on the idea that requirements can be clearly defined at the beginning of a project and that outcomes can be delivered exactly as planned. Curious. The first key characteristic is fixed scope. Requirements are defined upfront and rarely change. This allows teams to work within a controlled environment. The second characteristic is predictable timelines. Project schedules are created in advance, and milestones are tracked carefully to ensure deadlines are met. Size. The third characteristic is deterministic outcomes. This means that the final deliverables behave exactly as specified, with little to no variation. The core responsibilities of a traditional project manager include defining requirements, managing scope, controlling costs, coordinating teams, and ensuring delivery aligns with expectations. Success in this model is straightforward. A project is considered successful if it is delivered on time, within budget, and according to scope. This approach works well for systems like enterprise software, applications, and infrastructure projects where outcomes are predictable. However, this model begins to break down when applied to AI projects, where uncertainty and learning are central. Now that we understand traditional project management, let us explore what makes the AI project manager fundamentally different. What makes the AI project manager different? The AI project manager operates in a completely different environment compared to a traditional project manager. The most significant difference is that data becomes the center of everything. Curious. Instead of focusing only on requirements, the AI project manager must ensure data readiness, quality, and proper data pipelines. Without good data, the AI system cannot perform effectively. Size. Another key difference is probabilistic outcomes. AI systems do not guarantee results. Instead, they provide predictions with varying levels of confidence. This means you must align stakeholders with the reality of uncertainty. Exhales. Ethics and risk governance also become critical responsibilities. AI systems can introduce bias, fairness issues, and unintended consequences. As a result, the AI project manager must oversee responsible AI practices even after deployment. Additionally, AI projects require continuous delivery. Unlike traditional systems, AI models must be monitored, retrained, and improved over time. Success is no longer measured by delivery alone. It is measured by business impact and trustworthy AI behavior. This shift changes how you lead, plan, and evaluate projects. Now that we understand these differences, let us directly compare traditional and AI project management side by side. Traditional PM versus AI PM. This slide provides a direct comparison between traditional project management and AI project management across several key dimensions. First, scope. Traditional projects operate with fixed scope, while AI projects require adaptive scope that evolves as new insights emerge. Curious. Second, output. Traditional projects deliver features, while AI projects deliver intelligence in the form of predictions and insights. Third, data. In traditional projects, data plays a supporting role. In AI projects, data is central and drives the entire system. Thoughtful. Fourth, accuracy. Traditional systems are expected to produce exact results. In AI systems, accuracy is never guaranteed, and results are expressed as probabilities. Fifth, risk. Traditional project risks focus on schedule and cost. AI project risks include bias, model drift, and ethical concerns. Finally, delivery. Traditional projects are typically one-time releases, while AI projects require continuous updates and monitoring. The most important takeaway is that AI project managers manage probability, not certainty. This comparison highlights why applying traditional methods to AI projects often leads to failure. Now that we have compared both roles, let us explore the mindset shift required to succeed as an AI project manager.
From control to enablement. The transition from traditional project management to AI project management requires a shift from control to enablement. You are no longer just managing tasks. You are enabling systems, teams, and outcomes to evolve and improve. As an AI project manager, you must become a systems thinker. This means understanding how data, models, and outcomes are interconnected. You must also act as a data strategist. Data quality and readiness are not technical details. They are strategic priorities that determine project success. Another critical role is that of an ethics steward. You must ensure fairness, transparency, and accountability in AI systems at every stage. In addition, you serve as a business-to-technology translator. You bridge the gap between stakeholder expectations and what AI systems can realistically deliver.
The key takeaway is that AI project management is not just an upgrade of traditional project management. It is a completely new discipline. You are not managing code, you are managing learning, trust, and business value. As we move forward, we will build on this foundation. Now that we've compared AI project management with traditional project management, you can clearly see that AI projects operate very differently. But how exactly are these projects structured from start to finish? That's what we're going to explore next. In the following lesson, we'll walk through the AI project lifecycle and understand each phase from idea to deployment. Lesson 1. AI Project Lifecycle Overview, from Idea to Intelligent System. In this lesson, we are introducing the AI project lifecycle, which explains how an AI idea evolves into a fully functioning intelligent system. Unlike traditional projects, AI projects follow a dynamic and continuous process that extends beyond initial development. The lifecycle typically includes 4 major stages: ideation, development, deployment, and monitoring. These stages are not isolated. They are interconnected and often repeat in cycles as the system learns and improves over time. At the ideation stage, we identify the business problem and determine whether AI is the right solution. During development, data is collected, models are built, and systems are trained. Deployment takes the system into real-world environments, where it begins to interact with users and business processes. Finally, monitoring ensures that the system continues to perform effectively and adapts to changes. This lifecycle highlights an important reality. AI is not a one-time delivery. It is an evolving system that requires continuous attention. As an AI project manager, your role spans across all these stages, ensuring alignment with business goals and long-term value creation. Now that we have introduced the lifecycle, let us explore the objectives and key insights behind it.
The AI project lifecycle. This slide focuses on understanding the full arc of an AI project, from the initial idea to ongoing operation. The lifecycle is not linear. Instead, it operates as a loop where each stage feeds into the next and informs continuous improvement. The key objective of this lesson is to help you understand how AI projects evolve over time. From ideation to data and modeling, then to deployment and monitoring, each stage plays a critical role in delivering value. A key insight to remember is that AI delivery does not end at deployment. In fact, deployment is only the beginning of real value creation. Once the system is live, it must be continuously monitored, evaluated, and improved. This is because AI systems are influenced by changing data, user behavior, and external conditions. As a result, they require ongoing adjustments to remain effective.
The lifecycle diagram shown on this slide represents an infinite loop, reinforcing the idea that AI systems are living systems rather than finished products. Understanding this concept is essential for managing expectations and ensuring long-term success. Now that we understand the lifecycle concept, let us dive into the first phase, where AI projects begin.
Ideation and business framing. The first phase of the AI project lifecycle is ideation and business framing. This is where AI projects begin, and it is also where many of them fail if not handled properly. The first step is to define the problem. You must clearly identify the business challenge or decision that needs improvement. Without a well-defined problem, the project lacks direction. Next, you set success metrics. These should be business-focused, not just technical metrics like model accuracy. The goal is to ensure that AI outcomes align with organizational value. The third step is assessing feasibility. This involves evaluating whether you have the necessary data, skills, budget, and resources. It also requires asking an important question. Why use AI instead of simpler solutions like rules-based automation?
As an AI project manager, your responsibility is to prevent AI for AI's sake projects. This means ensuring that AI is used only when it provides meaningful value. Getting this phase right determines the success of the entire project. Now that we understand how projects begin, let us move into the most resource-intensive phase, data and model development. Data and model development. The data and model development phase is where raw data is transformed into intelligence. This phase is the most time-consuming and complex part of the AI lifecycle, often accounting for up to 80% of the total effort. The first step is collecting and preparing data. This includes cleaning, labeling, and validating data to ensure quality and reliability. Poor data leads to poor model performance. The second step is selecting and experimenting with models. This involves choosing the appropriate algorithms and running controlled experiments to determine what works best. The third step is training, validating, and testing the model. This ensures that the system performs accurately and meets required standards before deployment. It is important to understand that progress in this phase is not linear. Iteration is expected, and multiple cycles of experimentation are often required. As an AI project manager, your role is to manage uncertainty, timelines, and stakeholder expectations throughout this process. This phase builds the foundation, but the real challenge begins when moving into real-world environments. Now, let us explore the deployment and integration phase. Deployment and integration. The deployment and integration phase is where the AI system moves from the lab into the real world. This is a critical transition point where many AI projects face challenges. The first step is deployment. The model is integrated into an application, API, or system where it can be used in real scenarios. Next is integration. The AI system must fit seamlessly into existing workflows so that users can interact with it effectively. The third step is establishing a baseline. This involves measuring initial performance to understand how the system behaves in a live environment. Finally, security and compliance must be ensured. This includes access control, auditing, and meeting regulatory requirements. A common failure at this stage is the belief that success in testing guarantees success in production. In reality, many systems perform well in controlled environments, but fail when exposed to real-world conditions. The key rule is that deployment is not the finish line. It is a transition into a new phase of risk and responsibility. Now that the system is live, the focus shifts to maintaining and improving it. Let us move into monitoring and continuous improvement.
Monitoring and continuous improvement. The monitoring and continuous improvement phase ensures that the AI system continues to perform effectively over time. This is why AI projects never truly end. The first component is performance monitoring. You must continuously track accuracy, latency, and error rates to ensure the system is functioning as expected. The second component is drift detection. Over time, data patterns change, which can cause model performance to degrade. Detecting this early is critical. The third component is retraining and updating. Models must be periodically updated to reflect new data and maintain fairness and accuracy. The reason this phase is so important is that the world does not remain static. Data changes, user behavior evolves, and regulations are updated. If the system is not monitored, it can silently fail. As an AI project manager, you must ensure that systems are continuously evaluated and improved.
This phase transforms AI from a static solution into a dynamic, evolving capability. Now that we have explored the full life cycle, let us conclude with the key takeaway of this lesson. AI projects begin to prove value after deployment. The most important takeaway from this lesson is that AI projects begin to prove value after deployment, not before. Curious. In traditional projects, success is measured at the point of delivery. Once the system is handed off, the project is considered complete. However, AI projects operate differently. Deployment is just the beginning. Real value is created through continuous monitoring, iteration, and improvement. Thoughtful. This means the life cycle is not a straight path. It is a continuous loop where each phase feeds into the next. The AI project manager is responsible for overseeing this entire loop. The comparison is simple. Traditional projects deliver and end. AI projects deploy and evolve. Understanding this shift is essential for managing AI initiatives effectively and delivering long-term business value. Now that you understand the life cycle of an AI project, from planning to deployment, the next question becomes, what kinds of AI projects actually exist in the real world? Because not all AI projects are the same. In the next lesson, we'll explore the different types of AI projects you may encounter and how they apply across industries. Types of AI projects: predictive, generative, autonomous, decision systems. In this lesson, we are going to explore the different types of AI projects and how each type serves a unique purpose in solving business problems. Understanding these categories is critical because not all AI systems are built for the same objective. There are 4 primary types of AI projects. Predictive AI focuses on forecasting outcomes based on historical data. Generative AI creates new content such as text, images, or code. Autonomous AI operates independently within defined boundaries, making decisions or taking actions without human intervention. Finally, decision AI recommends or automates choices, often in high-stakes environments. Each of these AI types represents a different form of intelligence. Some are focused on insight, others on creation, and others on action. As an AI project manager, your role is to clearly identify which type of intelligence is required to solve a specific business problem. Choosing the wrong type of AI can lead to wasted resources, failed implementations, and poor business outcomes. In this lesson, we will break down each type in detail so you can understand how and when to use them effectively. Now that we have introduced the 4 types of AI projects, let us define the objective of this lesson: understanding what kind of intelligence you are building. Before building any AI system, it is essential to understand what kind of intelligence you are actually trying to create. Thoughtful. This slide focuses on the lesson objective and the importance of aligning business problems with the correct AI type. There are 2 key objectives in this lesson. First, you need to identify the 4 major AI project categories. Second, you must be able to match specific business problems to the appropriate AI solution. This is one of the most critical skills for an AI project manager. Serious. Even if execution is perfect, choosing the wrong AI type will guarantee project failure. This is because each AI system is designed to solve a specific kind of problem. For example, if your goal is to predict future outcomes, you need predictive AI. If your goal is to generate content, you need generative AI. Misalignment leads to inefficiency and poor results. This is why understanding the nature of intelligence you are building is more important than the tools you use. As a leader, your responsibility is to ensure that the chosen AI approach aligns with the business objective. Now that we understand the importance of choosing the right type, let us explore the first category: predictive AI. Predictive AI, forecasting the future. Predictive AI is one of the most widely used types of AI in business. It focuses on using historical data to forecast future outcomes. Curious. This type of AI helps organizations anticipate what is likely to happen next. Common use cases include customer churn prediction, where businesses identify customers who are likely to leave, demand forecasting, which helps optimize inventory and supply chains, and predictive maintenance, where systems detect potential failures before they occur. Predictive AI is highly data dependent. It requires large amounts of labeled historical data to train accurate models. The quality of the data directly impacts the performance of the system. This type of AI is also accuracy focused. Thoughtful. Most predictive systems rely on supervised learning, where models learn from past examples to make future predictions. As an AI project manager, your focus should be on data quality, defining clear accuracy metrics, and monitoring model drift over time. Predictive AI is powerful, but it is only as good as the data it learns from. Now that we understand how AI can predict the future, let us move into a different type of intelligence, one that focuses on creating entirely new content. Generative AI, creating new content. Generative AI represents a major shift in how AI systems are used. Instead of predicting outcomes, generative AI creates new content such as text, images, audio, video, and even code. Excited examples include chatbots and copilots that assist users in real time, content generation tools that produce reports and marketing materials, and code assistants that help developers write software faster. One key characteristic of generative AI is that its outputs are probabilistic. This means results can vary each time the system is used. Unlike traditional systems, there is no single correct answer. Curious. Another important consideration is the risk of hallucinations. Generative AI can produce incorrect or misleading information, which means outputs must always be verified. For high-stakes applications, human oversight is required. This is often referred to as a human-in-the-loop approach. As an AI project manager, your focus should be on safety, governance, brand risk, and prompt quality. Generative AI is powerful, but it must be managed carefully. Now that we have explored systems that create, let us move to systems that act and make decisions. Systems that act or decide. In this, we explore two advanced types of AI systems, autonomous AI and decision AI. These systems go beyond prediction and creation. They take action or make decisions. Autonomous AI operates independently within defined boundaries. Examples include robotics and logistics systems that optimize operations, as well as autonomous trading systems that execute financial transactions in real time. Decision AI, on the other hand, focuses on recommending or automating choices. This includes use cases such as loan approvals, fraud detection, and dynamic pricing. Surprised. These systems carry a higher level of responsibility because their actions directly impact business outcomes and people's lives. As a result, they require high accountability. Decisions must be traceable and explainable. Size. They also face regulatory exposure, meaning they must comply with laws and standards. Additionally, human override mechanisms must be in place. This ensures that critical decisions can be reviewed or reversed when necessary. These types of AI systems introduce significant risk and complexity. Now that we understand all four types, let us look at how to choose the right AI project type strategically. Choosing the right AI project. Choosing the right AI project type is one of the most important decisions you will make as an AI project manager. Thoughtful. This slide provides a strategic framework for aligning business needs with the correct type of AI. If the goal is to forecast outcomes based on historical data, predictive AI is the right choice. If the objective is to generate content such as text, images, or code, generative AI should be used. If the system needs to act independently within defined boundaries, autonomous AI is appropriate. And if the goal is to recommend or automate decisions, decision AI is the correct approach. One key principle to remember is that the more autonomy an AI system has, the higher the level of governance required. Serious. This includes stronger oversight, compliance measures, and risk management. The main takeaway from this lesson is that AI project managers do not just manage projects. They choose the right type of intelligence for the job. Making the right choice ensures alignment between business goals and technical execution. Now that you've seen the different types of AI projects, it's important to understand that these projects are not built in isolation. They involve multiple people, teams, and decision makers. So in the next lesson, we're going to focus on the key stakeholders involved in AI projects and the roles they play in ensuring success. Key stakeholders in AI projects. In this lesson, we are focusing on one of the most critical elements of AI project success, stakeholders. While many people believe that AI success depends primarily on algorithms and models, the reality is very different. AI projects succeed or fail based on alignment between people. Stakeholders are the individuals and groups who influence the direction, funding, development, and adoption of AI systems. These include business leaders, technical teams, risk and compliance professionals, and end users. Each group plays a unique role in shaping the outcome of the project. One of the biggest mistakes in AI projects is focusing too much on technical performance while ignoring stakeholder alignment. Even the most advanced AI model will fail if it does not meet business needs, comply with regulations, or gain user trust. As an AI project manager, your role is to ensure that all stakeholders are aligned around a shared vision, clear objectives, and realistic expectations. This requires strong communication, leadership, and the ability to translate between technical and business perspectives. Understanding stakeholders is not optional. It is foundational to delivering real value. Now that we understand why stakeholders matter, let us explore why AI projects fail without alignment. Why AI fails without alignment. This slide introduces a critical truth about AI projects. Most failures are not caused by poor algorithms or weak models. Instead, they are caused by misalignment among stakeholders. Size. Misalignment can occur in many ways. Business leaders may expect immediate ROI, while technical teams need time for experimentation. Compliance teams may raise concerns that are not addressed early. End users may not trust or adopt the system. Curious. The core truth is simple. AI projects fail more from misalignment than from bad algorithms. This highlights the importance of understanding stakeholder roles and ensuring collaboration across all functions. The objectives of this lesson are to help you identify key stakeholders, understand their responsibilities and influence, and recognize how misalignment leads to failure. As an AI project manager, your role is to align expectations, facilitate communication, and ensure that everyone is working toward the same goals. When alignment is achieved, AI projects can deliver significant value. When it is not, even the best technology will fail. Now that we understand the importance of alignment, let us begin with the first group of stakeholders, strategic decision makers. Strategic decision makers. Strategic decision makers are the business and executive stakeholders who define the direction of AI projects. These include executive sponsors such as CEOs, CIOs, and CTOs, as well as business unit leaders and product owners. Their primary responsibility is to define business objectives. They determine what problems need to be solved and what success looks like. They also approve funding and set the organization's risk tolerance. Ultimately, they are accountable for business outcomes. Serious. If these stakeholders are ignored or not properly engaged, the project may succeed technically, but fail to deliver business value. This often results in low adoption or wasted investment. As an AI project manager, your role is to translate AI capabilities into business value. Encouraging, you must ensure that technical efforts align with strategic goals and that stakeholders understand what AI can realistically deliver. Strong engagement with strategic decision makers ensures that the project remains focused on meaningful outcomes. Now that we understand the role of business stakeholders, let us move to the next group, the builders of intelligence. Builders of intelligence. Builders of intelligence are the technical and data stakeholders responsible for creating AI systems. This group includes data scientists, machine learning engineers, data engineers, and IT or cloud infrastructure teams. Their role is to design data pipelines, develop models, manage infrastructure, and optimize system performance. They are responsible for turning business requirements into working AI solutions. Size. However, if these stakeholders are ignored or misunderstood, it can lead to unrealistic expectations and delivery failures. Business teams may expect results that are not technically feasible, or timelines that are not realistic. As an AI project manager, your role is to bridge the gap between technical reality and business expectations. You must ensure that communication is clear, expectations are aligned, and constraints are understood. Curious. This requires a deep understanding of both technical processes and business needs. By effectively managing this group, you ensure that the system is built correctly and efficiently. Now that we understand the technical stakeholders, let us explore another critical group, the guardians of trust. Guardians of trust. Guardians of trust are the stakeholders responsible for ensuring that AI systems are ethical, compliant, and secure. This group includes legal teams, compliance officers, risk management professionals, data protection officers, and ethics committees. Their responsibilities include ensuring regulatory compliance, such as GDPR or AI regulations, overseeing bias and fairness, and maintaining privacy and security standards. Size. These stakeholders are essential because AI systems can have significant legal and ethical implications. If they are ignored, the organization may face legal exposure, reputational damage, or even project shutdown. As an AI project manager, you must treat governance as a foundational component of the project, not an afterthought. You must ensure that ethical considerations are integrated into every stage of the lifecycle. Thoughtful. Balancing innovation with responsibility is a key part of your role. By engaging these stakeholders early and consistently, you protect both the organization and the users. Now that we understand governance stakeholders, let us move to the most overlooked group, the end users and customers. The most overlooked stakeholder. The most overlooked stakeholders in AI projects are the end users and customers. Thoughtful. These are the people who interact with AI systems on a daily basis and are directly affected by their decisions. End users include employees who use AI-powered tools, while customers are those impacted by AI-driven outcomes. Their role is critical because they provide feedback on usability and determine whether the system is trusted and adopted. A key insight to remember is that if users do not trust the AI system, its accuracy does not matter. Emphatic. Even the most advanced model will fail if it is not accepted by its users. As an AI project manager, you must prioritize user experience, trust, and adoption. This means involving users early, gathering feedback, and continuously improving the system based on real-world usage. The final takeaway from this lesson is clear. Confident. AI project managers manage people first and models second. As we move forward, we will build on this understanding of stakeholders. You've now covered the core foundations of AI project management, including roles, differences, lifecycle, project types, and stakeholders. It's time to test your understanding. In the next section, you'll take a short quiz to reinforce what you've learned. Slide 1. Generative AI versus traditional AI systems. In this lesson, we explore one of the most important distinctions in modern artificial intelligence, the difference between generative AI and traditional AI systems. This distinction is critical because it shapes how products are built, how risks are managed, and how value is delivered. Traditional AI systems are designed to predict and classify. They analyze data and provide structured outputs such as labels, scores, or forecasts. Generative AI, on the other hand, creates entirely new content. It generates text, images, code, and more. This shift from prediction to creation represents a major evolution in AI capabilities. It also introduces new opportunities and new risks. As a project manager or product leader, understanding this divide is essential for making informed decisions. The visual on this slide highlights this contrast clearly. Traditional AI focuses on predicting and classifying, while generative AI focuses on generating and creating. This lesson will help you understand how these systems differ, when to use each one, and how to manage their risks effectively. Now that we have introduced the concept, let us define the objective of this lesson and what you are expected to learn. Slide 2. Not all AI predicts. Some AI creates. The objective of this lesson is to help you clearly distinguish between generative AI and traditional AI systems. While both fall under the umbrella of artificial intelligence, they operate in fundamentally different ways. By the end of this lesson, you should be able to identify the differences between these two types of AI, understand their use cases, and recognize the leadership implications of each approach. Curious. You should also be able to apply the right framework when making product and project decisions. The core insight here is powerful. The most important decision you will make is not which tool to use, but which type of AI to deploy. Size. Choosing the wrong type can lead to poor outcomes, even if execution is flawless. This lesson is also critical for certification. You should pay close attention to the distinctions because they are commonly tested concepts. Understanding these differences will help you align your AI strategy with business goals and risk tolerance. Now that we understand the objective, let us begin by exploring traditional AI systems, which focus on prediction and classification. Slide 3. AI that predicts and classifies traditional AI systems are designed to analyze data and produce structured outputs. These systems focus on prediction and classification, making them highly effective for decision-making processes. Curious examples include fraud detection systems that identify suspicious transactions in real time, credit scoring systems that classify financial risk, and demand forecasting systems that predict inventory needs based on historical data. These systems have several key characteristics. First, they produce structured outputs such as categories or numerical values. Second, they operate with deterministic objectives, meaning success criteria are clearly defined from the beginning. Third, they are easier to evaluate because performance can be measured using metrics such as accuracy, precision, and recall. Thoughtful. For AI project managers, the focus is on ensuring these metrics align with business objectives. Success is measured through clear and quantifiable KPIs. Traditional AI is reliable and predictable compared to generative AI. It is well suited for high-stakes environments where accuracy and consistency are critical. Now that we understand traditional AI systems, let us shift to generative AI, which introduces a completely different set of capabilities and risks. Slide 4. AI that creates new content. Generative AI represents a new frontier in artificial intelligence. Unlike traditional AI, which predicts and classifies, generative AI creates new content. This includes text, images, audio, video, and even code. Examples include chatbots and large language models that generate natural language responses, image generators that create visuals from text prompts, and code assistants that help developers write and optimize software. Thoughtful. While generative AI is powerful, it introduces unique risks. One major risk is hallucination, where the system produces confident but incorrect information. Concerned. Another risk is brand and legal exposure, as unreviewed outputs can lead to liability. Additionally, outputs can be inconsistent, meaning the same input may produce different results. Because of these risks, generative AI requires strong governance. Human oversight is essential, especially in high-stakes applications. Clear usage boundaries and policies must be established before deployment. As an AI project manager, your role is to ensure these safeguards are in place. Now that we understand both traditional and generative AI, let us compare them side by side to highlight their key differences. Slide 5. Traditional AI versus generative AI. This slide provides a direct comparison between traditional AI and generative AI across several important dimensions. Traditional AI focuses on prediction and classification, while generative AI focuses on creation and generation. Curious. Traditional systems produce structured outputs, whereas generative systems produce variable and probabilistic outputs. Accuracy in traditional AI is measurable and benchmarkable. In generative AI, outputs are less predictable and can vary with each use. This introduces a different type of risk. Size. The primary risk in traditional AI is prediction error. In generative AI, the primary risk is hallucination, where incorrect information is presented confidently. Traditional AI is commonly used for automated decision-making, while generative AI is used for content creation and assistance. Governance requirements also differ. Traditional AI requires moderate oversight, while generative AI demands strong guardrails and continuous monitoring. The key leadership rule is clear. Generative AI requires stronger governance, and these safeguards must be planned before deployment. Now that we have compared both systems, let us explore how to choose the right AI approach strategically. Slide 6. Choosing the right AI system. Choosing the right AI system depends on the nature of the problem you are trying to solve. This slide provides a practical framework to guide your decision-making. Thoughtful. You should use traditional AI when decisions must be explainable, when regulators or stakeholders require auditability, and when errors are costly. Traditional AI is ideal for high-stakes environments where precision and reliability are critical. On the other hand, generative AI should be used when creativity or language is required, when you need to generate content at scale, and when speed is more important than perfection. Curious. Generative AI works best in environments where rapid iteration is supported by human review. One key principle to remember is that generative AI amplifies both productivity and responsibility. While it enables faster and more flexible outputs, it also introduces higher risks that must be carefully managed. As a project manager, your role is to choose the right tool based on business needs, risk tolerance, and governance requirements. This concludes the lesson. In the next lesson, we will explore how to implement AI systems effectively, including workflows, deployment strategies, and operational best practices. AI, machine learning, and deep learning explained. Simply. In this lesson, we are going to simplify 3 of the most important concepts in artificial intelligence: AI, machine learning, and deep learning. These terms are often used interchangeably, but they do not mean the same thing. As a project manager, understanding the difference is critical to leading AI initiatives effectively. Artificial intelligence is the broadest concept. It refers to systems that can perform tasks that normally require human intelligence. Machine learning is a subset of AI, focused on systems that learn from data. Deep learning is a further subset of machine learning that uses advanced neural networks to process complex information. The goal of this lesson is not to make you a data scientist. Instead, it is to give you the clarity and confidence to lead AI projects without getting lost in technical jargon. Many AI projects fail not because of poor coding, but because of misunderstandings between teams. When stakeholders, engineers, and managers are not aligned on definitions, expectations become unclear. This lesson will give you the language to bridge that gap and lead effectively. Now that we have introduced the topic, let us begin by understanding why this knowledge is essential for project managers. You can't manage what you don't understand. As a project manager, your ability to lead depends on your ability to understand what you are managing. Curious. This is especially true in AI projects, where complexity and terminology can easily create confusion. The first objective of this lesson is to help you understand what AI, machine learning, and deep learning actually mean. Without this clarity, it becomes difficult to define scope, set expectations, and communicate effectively with technical teams. The second objective is to understand how these concepts relate to each other. Thoughtful. While they are connected, they are not the same, and treating them as identical can lead to poor decisions. The third objective is to know when each concept applies to your projects. Not every problem requires deep learning, and not every AI system uses machine learning. This knowledge matters because many AI projects fail due to misaligned expectations, unclear scope, and confusion in terminology. These issues often arise from a lack of shared understanding across teams. By mastering these concepts, you gain the ability to lead conversations with confidence and clarity. Now that we understand why this matters, let us start with the foundation: artificial intelligence as the umbrella concept. Artificial intelligence, the umbrella. Artificial intelligence is the broad field that encompasses all systems designed to perform tasks that typically require human intelligence. It is not a single tool or technology, but a category that includes many different approaches. Curious examples of AI include chatbots that handle customer support, recommendation systems that suggest products or content, fraud detection systems that identify suspicious behavior, and voice assistants that interact through speech. Excited. The key idea is that AI represents capability. It is about what a system can do, not how it is built. As a project manager, one important takeaway is that when someone says they are using AI, you should always ask what type of AI they are referring to. This helps clarify expectations and ensures alignment between stakeholders and technical teams. AI can be implemented using different methods, including rule-based systems and machine learning models. Understanding this distinction is important because it affects complexity, cost, and performance. Artificial intelligence sets the stage, but it does not explain how systems learn or improve. Now that we understand AI as the umbrella, let us move one level deeper into machine learning, where systems learn from data. Machine learning, systems that learn from data. Machine learning is a subset of artificial intelligence that focuses on systems that learn from data rather than relying on explicitly programmed rules. Curious. This represents a major shift from traditional software development. In traditional systems, developers write rules such as, if this happens, then do that. In machine learning, the system is given data and learns patterns from it to make predictions or decisions. This approach is widely used in business. Examples include predicting customer churn, assessing risk in financial systems, and forecasting demand for products and services. One of the most important principles in machine learning is that data quality determines success. Size. Poor quality data leads to poor outcomes, regardless of how advanced the model is. This is often summarized as garbage in, garbage out. As a project manager, your role includes ensuring that the right data is available, clean, and properly structured. Machine learning introduces the concept of systems that improve through experience, but it still has limitations when dealing with highly complex data. Now that we understand machine learning, let us explore deep learning, which takes this concept to a more advanced level. Deep learning, ML at scale. Deep learning is a specialized subset of machine learning designed to handle complex and high-volume data. It uses neural networks with multiple layers to mimic how the human brain processes information. This approach is particularly effective in areas such as computer vision, where systems recognize objects in images, speech recognition, where systems understand spoken language, and large language models that generate and analyze text. Excited. Deep learning often delivers high accuracy, especially in tasks involving images, speech, and language. However, it comes with significant costs. It requires large datasets, substantial computing power, and specialized expertise. As a project manager, it is important to follow a key rule. Curious. Only use deep learning when simpler machine learning approaches are not sufficient. Choosing deep learning unnecessarily can increase complexity, cost, and project risk. Deep learning is powerful, but it should be used strategically. Understanding when to use deep learning versus simpler models is a critical decision that impacts project success. Now that we have explored AI, machine learning, and deep learning individually, let us bring everything together in a clear and practical summary. Putting it all together. In this final slide, we bring together everything we have learned about AI, machine learning, and deep learning into a clear framework. Artificial intelligence is the broadest category. It represents the entire field of intelligent systems. Within AI, machine learning focuses on systems that learn patterns from data. Within machine learning, deep learning handles complex tasks using advanced neural networks. This layered structure helps you understand how these concepts relate to each other. Curious. It is important to remember that not every AI project requires machine learning. Many problems can be solved effectively with rule-based systems. Similarly, not every machine learning project requires deep learning. Simpler models are often faster, more cost-effective, and easier to explain. Thoughtful. As a project manager, your goal is not to use the most advanced technology, but to choose the right tool for the job. Complexity comes with cost, and it must always be justified by business value. The key takeaway is that smart project managers prioritize simplicity, clarity, and impact. Now that you understand the fundamentals of AI and machine learning, including how systems learn from data, the next step is to explore the actual technologies that power these systems. In the next lesson, we will break down the key AI technologies that are driving innovation across industries and how each one plays a role in building intelligent solutions. Key AI technologies. Every AI PM should understand. In this lesson, we explore the core technologies that power modern AI systems. As an AI project manager, you are not expected to build models, but you must understand the technologies well enough to lead effectively and make informed decisions. This lesson introduces 4 major areas of AI: machine learning, deep learning, natural language processing, and computer vision. Each of these technologies plays a critical role in different types of AI applications. Machine learning is the foundation, enabling systems to learn from data. Deep learning builds on this by using complex neural networks to solve advanced problems. Natural language processing focuses on understanding and generating human language. Computer vision enables machines to interpret visual information. The visual on this slide shows how these technologies connect and complement each other. Together, they form the backbone of most AI systems in production today. As a project manager, your goal is not to master the technical details, but to understand what each technology does and when to use it. This knowledge allows you to ask better questions and guide your team effectively. Now that we understand the landscape, let us define the objectives of this lesson and what you are expected to learn. Understanding the AI technology landscape. The objective of this lesson is to help you understand the AI technology landscape and develop the ability to work effectively with technical teams. You will learn to recognize the major AI technologies used in real-world projects and gain familiarity with how they function. Curious. This knowledge allows you to communicate clearly with engineers and data scientists. Another key objective is to help you ask the right questions. Different AI technologies solve different types of problems, and each comes with its own requirements. Size. Choosing the wrong technology can lead to delays, increased costs, or project failure. The core insight is that AI project managers are not required to code, but they must understand these technologies well enough to translate between business strategy and technical implementation. This ability makes you the bridge between stakeholders and technical teams. The key question to keep in mind is simple. Which AI technology is best suited for this problem, and what does it require from the team? Now that we understand the objectives, let us begin with the most foundational technology, machine learning. Machine learning, ML. Machine learning is the foundation of most AI systems in use today. It enables systems to learn patterns from data and make predictions or decisions without being explicitly programmed for every scenario. Excited. There are 3 main types of machine learning. Supervised learning uses labeled data where the correct answers are known. It is commonly used for classification and regression tasks. Unsupervised learning works with unlabeled data and identifies hidden patterns, such as customer segments or anomalies. Reinforcement learning learns through rewards and penalties, optimizing decisions over time. Real-world applications include fraud detection, where banks identify suspicious transactions, and recommendation systems, where platforms like Netflix and Amazon personalize content. As an AI project manager, your responsibility is to ensure that sufficient, high-quality data is available before committing to a machine learning solution. Poor data is the most common reason AI projects fail. Understanding machine learning helps you evaluate feasibility and risk early in the project lifecycle. Now that we understand machine learning, let us explore deep learning, which powers many of today's advanced AI breakthroughs. Deep learning. Deep learning is a specialized form of machine learning that uses neural networks with multiple layers to learn complex patterns in data. It has driven many of the major advancements in AI over the past decade. Excited. This technology is used in applications such as image recognition, speech recognition, autonomous vehicles, and medical diagnostics. For example, deep learning models can identify objects in images, transcribe speech into text, and detect anomalies in medical scans. Curious. One key difference between deep learning and traditional machine learning is that deep learning automatically extracts features from raw data. This eliminates the need for manual feature engineering, making it more powerful but also more resource-intensive. Size. Deep learning requires large datasets, significant computing power, and longer training times. These factors increase costs and complexity. As a project manager, you must evaluate whether the benefits justify these requirements. Not every problem needs deep learning. Understanding these trade-offs helps you make better strategic decisions. Now that we understand deep learning, let us move to natural language processing, which focuses on human language. Natural language processing, NLP. Natural language processing enables machines to understand, interpret, and generate human language. It is one of the most visible areas of AI because it powers many user-facing applications. Excited examples include chatbots and virtual assistants that handle customer inquiries, sentiment analysis tools that monitor brand perception, and machine translation systems that convert text between languages. NLP is also used for spam detection and document summarization. These applications demonstrate how AI can interact directly with humans through language. Curious. As an AI project manager, you must pay close attention to data preparation in NLP projects. Language data must be diverse, properly labeled, and relevant to the domain. Bias and inaccuracies in the data can lead to poor model performance or unintended outcomes. Size. NLP projects also require careful evaluation to ensure outputs are accurate and appropriate. Understanding NLP allows you to design systems that improve communication, efficiency, and user experience. Now that we understand how AI works with language, let us explore computer vision, which